In this video, we will investigate an advanced method for finding an antiderivative, something called the generalized power rule. And in order for this to make sense, let's just recall what the chain rule would tell us. If for some strange reason we wanted to differentiate a function of this form, g of x to the n plus 1 over n plus 1. What the chain rule would tell us to do is we differentiate the outside function. So the n plus 1 comes down front, the n plus 1's cancel, the new power is n, and then we multiply by the derivative of the inside function. So what that tells us is that g of x to the n plus 1 over n plus 1 is an antiderivative of g of x to the n times g prime of x. So if we ever see this form for the integrand, we can undo it with this generalized power rule. And just to maybe foreshadow a bit, in the next chapter, this is something that we will eventually refer to as a substitution. So let's use this generalized product rule to evaluate a few examples. So in terms of that generalized product rule, I'm thinking of the x squared plus 4 as playing the role of g of x. And note the derivative of x squared plus 4 is 2x. So perfect. This is actually the integral of g of x to the 10th times g prime of x dx. So by the generalized power rule, the value of n is 10, so this will end up being just the function g of x raised to the n plus 1 divided by n plus 1 plus c. So without any more work, since we've made the observation that it's a generalized product rule, the value of this indefinite integral is going to be x squared plus 4 raised to the 11th power divided by 11 plus c. Now you might be looking at this and think, why do we need the generalized power rule? So an observation to make where it says product, that should be power, I apologize. Why do we need this generalized power rule? Well, you could use the previous methods, but that would require us to expand out x squared plus 4 to the 10th. Sure, given enough space on the paper and enough time, we could do that, but maybe we turn that 100 into 1,000. Then all of a sudden the previous methods would not work efficiently at all, and this generalized power rule would work extremely efficiently. So once again, let's use the generalized power rule to evaluate the following indefinite integral. And the first thing I'm going to do is just rewrite slightly. I'm going to write this as an integral of sine x quantity cubed times cosine x. And I think this makes it a bit more clear. You see this function g of x, which would be the sine, which is kind of this inside type function which is being raised to a power. And outside of that function being raised to a power is, guess what? It's derivative. The derivative of sine is cosine. So what we actually have here is the integral of g of x cubed times g prime of x. So by the generalized power rule, this is going to be g of x to the 4th over 4 plus c. So since we've made this connection, no more work is required. We take our function g of x, which is sine, we raise it to the 4th power, we divide it by 4, and we add c. Now I realize that this might work out in a way that just seems almost too good to be true, so let's do our double check. If we differentiate 1/4 sine to the 4th, let's verify that we get back what's in the integrand. So by the chain rule, the 4 comes down front, so we have 1/4 times 4. Our new power of sine is 1 less, and then we multiply by the derivative of that inside function. And the derivative of sine is cosine. So the 4 over 4 cancel, and what we're left with, the sine cubed over cosine, is exactly the integrand function. So check